The gradient. We're going to talk about three operators in the coming videos: gradient, divergence, and curl. This video will be about the gradient. If we have a scalar function, f of x, y, z, the gradient is just the x partial I plus the y partial j plus the z partial k. That takes a scalar function, produces a vector. We can put an arrow over this to indicate that that gives us a vector. One geometric property we'll illustrate in a minute is the gradient is a vector which is perpendicular to something called a level curve. Now, if we take a simple function, f of x, y equals x squared plus y squared, and this is just a function of two variables. If we want the gradient of a two-variable function, we just take that off. If it's a function of three variables, this would be perpendicular to what's called a level surface, but we won't get into that in this short video. F of xy is x squared plus y squared. That's just a simple elliptic paraboloid. Now the gradient, the x partial, is 2xi plus the y partial, 2yj. Very simple operation. Now you can take a level curve. If we said f of xy equal to 4, that would give us a level curve where z equals 4. This would be a z coordinate, and of course if you set the function equal to that, that's a circular radius 2. And so you can graph that as this. Now one point is right here, 2, 0, for instance, x equals 2, y equals 0. If you were to look at this from a three-dimensional standpoint, this is what it would look like. There's a level curve. But we're just looking at it here. Now, you can evaluate the gradient, 2, 0, x is 2, y is 0. So we want to put a 2 there and a 0 here. And we get 4i. Now, if you go to this point, you graph a 4i vector. It just goes like this. And you can notice that's perpendicular to this level curve. If you were to draw a tangent line right here, that is perpendicular. Well, you can move all the way around the circle. You can evaluate the gradient at any point on the circle, and it's going to look like that. I can predict that without actually evaluating it. And that's true. You can change up the level curve, do it at any level. This could be any surface. I picked a simple one that we can visualize. So what's important to note is we start with a scalar. This is a scalar function here. There's no I, j, or k. And then we end up with a vector. So we have a couple more operators we'll talk about, and div and curl. It's important that we know the various properties of these. And we'll also use a gradient when it comes to studying something called a conservative vector field, which we'll do in a couple of days. We'll use this concept of a gradient. So pretty important operator. That's all for this short video.